All right, what's up? Let's do some normal distribution calculations here today. So this differs from the empirical rule in that we'll find some percentiles for stuff that does not fall exactly one or two or three standard deviations away from the mean. So we've got these scores here for the adult intelligence scale, some type of IQ test for people aged 20 to 34. If it's approximately normal, that's important. That means normal calculations apply, or like z-scores in table A. It's distributed with a mean of 110 and a standard deviation of 25. So at what percentile is an IQ score of 150? So just like we did with the empirical rule, you would want to sketch a distribution. Not anything I'm good at, but right here in the middle would be the mean of 110, and then we go 3 standard deviations to the right, 3 standard deviations to the left. And so this score of 150, so we know that the mean is 110 rather. If I go with my standard deviation here, I'm going to have 135. Add another 25, I get to 160. Add another 25, and I get up to 185. Now, going in this direction, that would be a score of 85, 60, and on the low end here, 35. So 3 standard deviations to the right, through the left. Now, what percentile is an IQ score of 150? So that's an issue. We don't know exactly where 150 is going to land. What score puts us there? Is that where 150 goes? We don't really know. So to get around that, you could create a new distribution, but instead of using these actual statistics, these values, what you would do is use z-scores. We're going to standardize this stuff. So again, instead of having to use the values given to us up here, these values with units, we can standardize and apply these calculations to any distribution with any mean, any standard deviation, any unit. So I'm going to re-sketch this one more time, but not use these values up here. Should make it easier for us to do. So again, I'm just going to go like this. And instead of using like x values, I'm using z's for my axis down here. I'm using z-scores. So that would mean the mean is 0. This is the standard normal distribution. It works for any normal distribution, for any units, any values. This will be 1, 2. This would be a z-score right here of 3. And we're going to do the same thing in this direction. So I've got -1, -2, and -3. Okay, so at what percentile is an IQ score of 150? Well, now we know what we can do is just get the z-score. Let's find the z-score for this value. Z equals 150 minus the mean of 110 divided by the standard deviation of 25. So that means z is equal to 40 divided by 25. I can work on reducing this. That's the same thing as 8/5. And we're going to round this to 2 decimals. So I'm at 1.60. 1.60. So I know I'm going to be about right here. Now, to find the percentile of this, it's where 1.6 goes. To find the percentile, so that's anything less than or equal to that value. Anything less than or equal to that value. So, hey, what I'll do is shade this in, what I'm trying to find. I'm trying to find the percentile. So anything less than that value. So you'd be shading in all of this stuff, which on this very cool pen I bought is not easy to do. But that's the gist of it, right? We need to find this probability. And there's something that will give you this probability. That something is called table A. Table A. So let me pull that table up. We'll find the probability associated, or the percentile associated with a z-score of 1.60. I'm going to have to clear all this. Let's go like this. Fantastic. So hey, the z-score, right? I had a positive z-score. I had a positive 1.6. So let's look for that first. I mean, the negative values, I get up to 0 in the right direction. This looks like more of what we're doing because our z-score was greater than the mean. So anyhow, keep going, 1.6, and it was 1.60. So here's the 0 column, line that up with 1.6. That's what we're looking for, 0.9452. And that was 0.9452. 0.9452. So what percentile is an IQ score of 150? Approximately, I'm going to round a little bit, that it means if you had an IQ of 150, you'd approximately be in the, I'll round up and just say 95th percentile. Okay, and that would do it for the first question. We're going to use that strategy for the next few questions. We don't have to worry about sketching the distribution with the actual mean and the actual standard deviation. Too much work. So let's move on. Part B, what percent of people aged 20 to 34 have IQs between 125 and 150? Okay, so to do this, again, we'll sketch a distribution. We're going to do the standard normal distribution. So we got the mean here of 0. I got my x-axis being a z-score. So put 1 like over here, 2 over here, third standard deviation over here. We'll go this direction too, just for fun. -1, -2, and -3. Okay, so we already did the z-score for 150. The z-score for 150, we did that on the previous problem. That came out to 1.60. Now let's find the z-score for 125. Z-score for 125 equals that observation minus the mean, which was 110, divided by the standard deviation of 25. So 125 minus 110, that's going to give you 15. Doing 15 divided by 25, I can reduce that to, that would be 3/5 or 0.60. Okay, so I have a z-score at 125. Z-score of the observation 125 is 0.60. So 0.160, that's a little bit more than halfway between these two. Again, this is why the empirical rule wouldn't apply. That's just going between the actual whole number standard deviations or integer values. So z-score, the other one that I'm looking at is 1.60, which was about right here. Okay, so I'm looking, what percent of people have IQs between these two amounts? So this is the area that you would then shade in and try to calculate. So whenever you have this kind of a question where you have to find an interval between two amounts, you are going to want to subtract their percentages, not their z-scores. So do not do 1.6 minus 0.60. We're going to find the percentages for each one. So this z-score of 150, we already know from table A, it has a proportion or a percentage of 9452. Now let's go back to table A and see what this z-score at 125 looks like. The z-score for the observation at 125. So I'm looking for 0.60 in table A. 0.60 in table A. 0.60 in table A. Okay, let's go to table A and 0.60. So here's 0.6. This is 0.60. So these guys line up at 0.7257. 0.7257. All right, so let's write that down. 0.7257. Okay, bring all that back. 0.7257. Okay, so now that we know 94% of the observations are less than this amount, 72% are less than that amount, we can subtract those two percentages to actually find this range of values. So again, I'm essentially finding the probability that someone scores between a 150 and a 125. So I will do, to answer this question, 0.7257 0.9452 minus 0.7257. So my percentage would be then 0.9452 minus 0.7257. I'm just going to round on this one and say that's roughly equal to 0.22. You can't do that, I can. That's going to be roughly equal to 22%. 22% of people that take this IQ test are going to have a score between 125 and 150. Hopefully you found that pretty enlightening. Okay, let's move on to part C here. The last thing that you would kind of have to be able to do. So Mensa is an elite organization that admits as members people who score in the top 2% on IQ tests. What score on this particular test would have an individual, or would an individual have to qualify for Mensa membership? So, kind of working backwards on this one. Top 2% get in. So if we were thinking about this in a curve, I'll just do a very rough sketch real quick. If I was doing a curve of this, like that, we know the mean score is going to go here, of course. Here's 1, here's 2, here's 3. All right, so I'm looking for 98% of my values then, right? So essentially, I want 2% of scores, so probably somewhere around here to be shaded in. What value gets me there? What value puts me here? What we can do is find the z-score for it, the z-score for the top 2%. I'm using this because I wanted the top 2%. I don't want the bottom 98%. But that's what we're going to find in Table A. Table A only finds less than probabilities. It does not show you greater than probabilities. That's what this question is asking us to do. So the top 2%, that is the same thing as the bottom 98%. Essentially, you want a score that's better than 98% of these observations. So let's go ahead and find out what that z-score is. What z-score puts us here? Again, I'm going to have to travel back to Table A. I'm working backwards, right? So these are my percentages. I'm trying to find one, like the closest z-score to 0.98. So if you're looking at this table, I know there's a lot going on, but we've got 0.9798 and 0.9803. Those are both incredibly close to 0.98. But this one is only two ten thousandths closer. This one's a little bit closer than this one, just a tad, right? 0.0002, where this distance to 0.98 is 0.0003. So let's use this percentage for our z-score. That would make our z-score 2.0, I'll look up here, 2.05. 2.05. All right, so let's go back. Getting that probability corresponds to a z-score of 2.05. Okay, but it's all well and good. We want to know though, what actual IQ score is going to put us at a z-score of 2.05. And it's going to come from this formula. So we know that z equals our observation minus our mean divided by our standard deviation. So let me plug some of that stuff in. I know my z-score is 2.05. Trying to find this observation that gets me there. I know the mean is 110, and I also know that the standard deviation is 25. So essentially all we're doing is solving for x here. So to do that, right, I'd have to cancel out that denominator first. 25 times 25, they'll cancel each other out. Multiply the other side by 25. So 25 times 2.05, that is going to give you, I don't know, let's do it on a calculator. Is it 51 or like more than that? We're doing 25 times 2.05, 51.25. I probably should have been able to do that. So 51, or I'm sorry, 51 151.25 equals x minus 110. If I add 110 to each side of my equation now, add 110 there, add 110 here, you're going to get 161.25. So in order to get admitted into Mensa, you would have to score at least a 161.25. If any score lower than that, you would not be in the top 2%. All right, guys, that's going to do it for this video. Thanks for watching. I'll see you in class. Okay, bye.